Hi guys, these are going to be the lecture notes for our chapter on interest rates. We're going to look a bit about interest rates, how we calculate bond prices, the relationship between interest rates and bond prices, and whatnot. Just as a precursor, I kind of go through bond pricing relatively quickly because it's not something I spend a lot of time on in this course. For those that are in finance, you will see a lot more detail in some of your upper level finance courses. For those in econ, you get enough of the material to understand what's going on, and that's my point. Is that I want to get into more of the economics, not just memorizing equations. Okay, so what are we going to talk about in this chapter? We're going to look at really three things. As I mentioned, what are interest rates? In short, interest rates are the cost of borrowing money or what you give up when you spend money. Right? Depends on if you are a borrower looking to start an investment in maybe a home, a car, a company, right? You're paying the cost of borrowing money, which is the interest rate. Or if you're someone that has excess money and you want to save it, you decide to spend it, what are you giving up? The interest rate you could earn. We're going to talk a bit about how we calculate bond prices. Largely, this is just going to be some technical stuff to cover. I'm not going to spend a lot of time with it. And then what is the relationship between interest rates and bond prices? So, continuing here are the learning objectives, right? Calculate the present value, future value, understand the difference between yield to maturity, current yield, rate of return, capital gain, all that fun stuff, and then interpret the distinction between real and nominal interest rates. I'll make sure throughout the lectures to point out, okay, this is really important, be sure to pay attention, or if it's something that's going to be, okay, I want you to see it, make sure you understand it, but it's not as critical, I'll be sure to flag that as well. So when we talk about interest rates, there are all sorts of different interest rates out there. There's not just one set interest rate. Most of us are familiar with putting money in the bank, getting a savings rate. That is really a low interest rate, largely because that interest rate is what the banks pay you to borrow money, and it's based off of what banks could get elsewhere. So as we go through these interest rates, the main ones we focus on are what we call commercial paper. Commercial paper is a short-term interest rate, so a lot of corporations will use to fund kind of short-term daily operations. It's usually a short-term maturity, usually about 30 to 90 days. Sometimes they can be as short as one day. Other times it can be as long as 270 days. Federal funds rate, that is the interest rate that the Federal Reserve sets. It's bank-to-bank lending, and this is really what governs the interest on your savings account. Banks are the ones that are borrowing money from us. So if they can borrow money from another bank at, say, 0.50 percentage points, they're not going to pay us more than that. In fact, they pay us actually a little bit less than that because there's a little bit of concern that we might want our money at any given point in time. Corporate bonds, pretty basic right here. So corporate bonds are going to largely focus on long-term borrowing needs of corporations. Government bonds, these are going to be what we call our riskless bond. That is the bonds issued by the U.S. Treasury. All sorts of different maturities, 30, 60, 90-day type of loans, 180-day, 360-day, so 1 year, 2-year, 3-year, 5, 7, 10, 20, 30-year notes. There's some discussion of issuing even a 40-year, 50-year, 100-year government bond, taking advantage of the low interest rates we're currently seeing. Conventional mortgages, student loans, car loans, these are typically slightly higher interest rate loans because they are longer duration, but they will closely follow that 10-year government bond. We'll talk a lot about how these interest rates are determined, how banks help play a role in this market in determining these interest rates as we go throughout this course. So as I already mentioned, what are interest rates? Really simple interest rates are the cost of borrowing money, right? It's the opportunity cost. When you want to borrow money, it's what you pay. You borrow $100 today, 5% interest rate, pay it back in 1 year, it's $105. So when we look at companies that are borrowing money to fund capital projects, the cost really isn't the capital project itself because you're actually building an asset. The cost is the cost of borrowing the money. And that asset, as it depreciates, that would also be a cost, the depreciation. Interest rates are important because they play a big role in the stock market and other assets. If you think about home prices, as interest rates go down, gets cheaper to borrow money, so the value of housing goes up, all these sorts of things. What determines interest rates? Lots of factors we'll talk about. Risk being the primary one. How likely are you going to pay back the loan? Time, the longer you need the money, typically comes at a higher interest rate. And then the amount. There's kind of two thresholds there. Low amount loans typically come at a higher interest rate because it's just there's not a big return there in dollar amount for the lender. Whereas there's sort of a sweet spot, but then once you get into larger loans, again, there's a little bit more risk there, so it comes at a higher interest rate. And then lastly, we'll look at how interest rates determine asset prices, stocks, bonds, real estate, things like that. So when we sit here and talk about how we value an asset, one really key thing we need to understand is when we value an asset, whether it's a piece of property, a company, a stock or a bond, the key variable we look at is cash flow. How much money do you get and when do you get it? So when you're considering buying a U.S. Treasury or a municipal bond issued by a local government, what you want to focus in on is how much money am I getting? Most of these bonds will pay a coupon payment, which is a fixed amount of money every year until the bond matures. When you get your money back. So we need to then figure out, well, if this bond is going to pay me X dollars every year and then pay me X dollars when it expires, matures, how much is that bond worth today? So to do that, we need to go through some basic future and present value concepts. Nothing too complicated, but something we certainly want to kind of go through. So here's a whole bunch of terminology for you. Future value, right, is if you make some investment today, what's the value of that investment at some point in the future? Compound interest, when you put money in the bank, you earn interest. If you keep that money in the bank for a longer period of time, the interest you've earned also starts accruing interest. So that's compound interest, is interest earned on interest. A basis point, a lot of times you'll hear a phrase like, oh, the bond went up 10 basis points or 25 basis points. That's really just the fraction of a percent. So 1 basis point is 0.01%. So 25 basis points is 0.25%. 100 basis points is 1%. Present value is the value of an asset today, accounting for all of its future cash flow. Rule of 70, rule of 72. If you take 72, really simple example here. If we take 72 and divide it by the interest rate you earn on an asset, say 6%, it's the number of years it takes for an asset to double in value. So if you put $100 in the bank and earn 6%, it would take 12 years for that $100 to double to 200. So, and again, that's part of the compound interest factor going on there. But the rule of 72 largely just says, take 72, divide by the interest you earn on an asset, and that's the time it takes for that asset to double in value. Internal rate of return, a lot of times companies will know the cost of an investment and they'll know how much that investment will pay off. So they got to figure out, well, what's the return to me? Suppose it costs me $1 million to build this store, and this store is going to yield $100,000 a year of revenue or of profit. What's that worth to me, right? For 20 years, then I'm going to sell it. What's that return, right? So in other words, $1 million investment yields $100,000 per year for 20 years. So we're going to talk a little bit about how we use internal rate of return. So again, just a bunch of key terms here, right? Okay, so when we start, let's start with future value and compound interest. So we're going to do a real simple example, and first we're going to start with $100, right? We're going to invest $100 today, and it's going to earn 5% interest. So real simple, in 1 year, how much do you have? You have $105, right? We take that $100, we multiply by 1 plus the interest rate, which is 0.05%. which is 100 times 1.05 or $105. So easy, right? So obviously the future value of $100 invested for 1 year at 5% is $105. Piece of cake, right? So this is what we call really a simple interest rate calculation. Same thing as if it were a loan, simple loan. You borrow money, you pay back in 1 year. There's no compounding here. It's just a simple loan where how much, when do you owe me, and then that's how we figure it out. All right, the next step's gonna be a little bit more. So in general, that calculation I just did of the $100, right, is $100 plus 100 times the interest rate, which is the same as 100 times 1 plus the interest rate, right? Factor out the 100, right, which gives us 100 times 1.05, or 105. Right, so really basic. So for a 1-year simple interest rate loan, that's how you do it, right? I will always give you have $100 today, this is due in 1 year, this is your interest rate. Right, when we go to multiple years, it gets a little bit more complicated, but still pretty simple, as you'll see here in a second. So a couple things you'll notice real quick: the higher the interest rate, or the higher the amount vested, the higher the future value. Really basic. Now, most financial instruments are not this simple, because oftentimes repayment might be a different period of time, multiple years, payment due every month. Most loans, mortgages, car loans, student loans are for 4, 5, 6 years, 10 years for a student loan, 20, 30 years for a mortgage. Typically require monthly payments, but then the interest rate is compounding daily. So you might have a 5% annual interest rate. They take that daily, and there's a daily interest rate that is accruing each day. So again, there's all sorts of complications in here. Most of those details, if you go into finance, you'll spend a lot more time with. For our purposes, they're not as critical. So just keep that in the back of your mind, that these calculations are really simple. Certainly they can get much more complicated. All right, so as I said, if we now do the future value of a loan for 2 years, right? So this one's a little bit pretty much the same kind of situation, right? Where what we're gonna do now is we're gonna get that $100, right? So that's what you get the first year. And then at the end of the first year, we get $100 plus what we earn in interest, right? And now we're gonna keep this money in the bank, right? And so if we keep in the bank for 1 more year, we get another $100 plus what we earn in interest. And this is the compound piece, right? This amount that we earned the first year, we earned $5 in interest from year 1 to year 2. And then we're gonna get another 5% on that money, right? So when we do all this, really what we're getting is 110.25, right? So this is the compounding part. Right, so in the end, what we end up with is this. If you look at and recognize what kind of polynomials look like, really you end up with $100 times 1.05 times 1.05, right? Because there was 105, we just pulled out that 5 right up here, right? So really we get $100 times 1.05 squared. More generally, right, which is 110.25, right? So more generally, the future value of any investment n years in the future is the value you start with today times 1 plus the interest rate raised to the number of years. So 2, 3, 4, 5 years, right, raised to the 2, 3, 4, 5. So that's how we're going to do kind of a simple loan over multiple years. Kind of to highlight how it gets a little bit more complicated is, as I talked about earlier, in finance, you'll deal with a lot more complicated payment streams, even adding a few more wrinkles in variation and timing. What if a loan is for 30 months as opposed to 3 years? How do you handle that? What if the interest rate is compounded monthly? How do you handle that? So really simple way of doing it is, if the interest rate's annual, just converting to months, one simple thing is you could do it one of 2 ways. We could then just take the interest rate and make it monthly, right? You can do a 1-month interest rate, and then you would do 1 month, and then you would do, your n would be the number of months. So that would work out almost the same way. Really basic, pretty simple way of going about it, right? So that would be one way you could deal with the months. If you're doing something 40 months, right? Take a monthly interest rate and do it for 40 months. So that's one way we can handle it. Another way we can do it, right, is do it for annual, but 1 over 12 months. So here's a really simple example, right? We know 5%, right, interest rate for 12 months, 1 year would give us 105. So what's the monthly interest rate then? Well, you just take the 105 and raise it to the 1 over 12, right? And then your monthly interest rate would be this thing. Really, it's 0.41%. That captures the monthly compounding and whatnot. So a little bit different, right? The monthly yield for 5%. So you don't just do 5% and divide by 12, right? That won't get you there because you have to account for the monthly compounding. So that's how you would get there if you wanted to do it monthly. So suppose I give you a problem that says, hey, using the simple interest formula, what's the future value of $1,000 today at a 6% annual interest rate for 42 months, right? What you would do is you would have to get the monthly interest rate first, this thing here, and then you would just apply that normal future value formula. So again, just keep that in mind as you go through some of the timing. Make sure if it's in years or months, you're using the right interest rate. So the other way of going about this, and this is really more of when we buy a financial instrument, what we have to account for is, well, I'm going to get money in the future. So what's the value to me today of that money, right? If you're buying a stock or a bond, or you're thinking of buying an investment property, you're going to get your money over time. So you need to figure out how much is that property worth, or that investment worth, that stock or bond today. So doing that is the present value, right? What's the present value of this future cash flow? And again, it's the same formula. We're just going to kind of convert it a little bit. Pretty simple, right? So present value as a term, right, is the value today in the present of payment that is promised to be made in the future. And the big thing when we do present value is to focus in on how much money we get and when do we get it, right? Those are the two questions. How much, erase, how much, and when. And we'll do a timeline here to help this, but this is really the biggest thing of any financial instrument. It's the same concept, and there's financial calculators or just even Excel makes this really easy to do. So to kind of find the present value, we're going to just start with our future value formula equals the present value times 1 plus our interest rate raised to the n. If we divide 1 plus I to the n on both sides, we get our present value formula. And really, this piece here is what we use every time you get a payment. So if you're looking at a stream of payments, so let's do an example. Suppose we were doing a real stream of payments where in year 1, 2, 3, 4, and in year 1 you get $50. In year 2 you get $100. In year 3 you get $200, and in year 4 you get $400. And I ask you, well, what's the value of that today? How much are you willing to give up today to receive this future stream of money? And you're going to go and you're going to look at the market interest rate, and let's suppose that market interest rate right now is 4%. So the present value of this payment stream is how much money do I get and when do I get it? I get $50 in year 1. I get $100 in year 2. So I'm just updating how much money I get, $200 in year 3, just 0.04, year 3, and then $400 in year 4. And you would just throw that into a calculator, into Excel, and you would solve it, and you would get your answer. Doing some quick calculations, $50 in 1 year to you is worth about $48.08 today. So that's how much you would give up today for just $50 in 1 year. You would give up $92.46 for $100 in 2 years. You would give up $177 and about 80 cents for $200 in 3 years, and then you would give up today $341.92 for $400 in 4 years. We would add all these up, and you would get a total of, I got to go over to my Excel sheet on my laptop, $660.80. $1.25. That's how much this is worth to you today for this future stream of money. So again, present value, and this is what you're going to learn when we do fixed payment loans and bonds, coupon payments. It's all about knowing how much money you get, the time period in which that money is delivered, and the interest rate you're earning on that money. So again, doing the generalization, the future present value of any payment stream is equal to the future value divided by the discount term. This is sort of the discount factor, right? We're lowering it. 1 plus I is something bigger than 1, so we're deflating the future value to bring it to today's dollars. I will say, yes, interest rates are always typically assumed to be positive. That may not always be the case, so oftentimes people ask, well, what's more valuable, $100 today or $100 in the future? And typically the answer is always $100 today. But in some environments, we're seeing negative interest rates, deflation, so $100 might be more valuable in the future under those kind of unique circumstances. But for the most part, right, the present value of something's always more valuable for the same amount of money. So just like with future value, some similarities here, right? The higher the future value of the payment, the greater the present value. The shorter the time payment, right? We saw $50 in 1 year was worth $48 to us today, right? So you really weren't getting a big return, whereas $400 you paid only $341 for. So the longer the time period, the lower the present value, right? You have to wait a long time. And then this is the biggest one, is the interest rate, right? In this formula here, the future value equals the present value over 1 plus the interest rate. You can quickly see as the interest rate goes up, the future, oh, I rewrote this wrong, make that a P, sorry, the present value equals the future value, right? And so as the interest rate goes up, right, you're willing to give up less today, because the other way you want to think about it is, well, at a higher interest rate, I could put my money in the bank and it earns a return faster in the bank than it otherwise would have. Kind of some interesting things to note. Doubling the future value of the payment without changing the interest rate will automatically double the future value, right? So if instead of getting $50, you get $100, all else equal, then the present value of it also doubles, right? The sooner the payment to be made, the more it is worth, right? Makes sense. All those things, just some things to kind of keep in mind. A lot of students like this timeline approach, and this highlights what I was saying in terms of how much you get and when you get it, right? If in the first year, right, $100 is worth $100, right? Year 1, year 0, 100 is worth 100. In year 1, right, we discount it by the factor raised to 1. In year 2, we're raising it to 2. In n years, we raise it to n years. All these questions are doing the same thing. It's simply just laying out when you get your payment stream, what year do you get it, how much do you get, and then you discount it by those factors. So again, pretty basic, right? Simple present value, shouldn't be too complicated for anyone. So now a little bit of a slightly different term is called yield to maturity. And this is more in financial assets, since most times in a financial asset, what's already determined is the price you pay and what you get in the future. And so what you're determining is, well, what's that interest rate? So if you're paying $100 today for a payment of $110, what is the yield? What are you returning? And so the yield to maturity is a little bit different. Still going to be the same principal formula that we're going to talk about. So here, real simple example, the one I just laid out, right? Present value is $100. You get $110 in 1 year. So you give up $100 today for $110. What is that interest rate? And so we're using that same formula. The present value equals the future value divided by 1 plus the interest rate raised to the n. And we're going to solve for the interest rate, right? That's the key here. So we have $100 equals 110. 1 plus I raised to the 1. So obviously we're solving for the I. So we're going to rewrite this as 1 plus I equals 110 divided by 100, right? And then that's going to give us 1 plus I equals 1.10. I equals 0.10, or 10%. So the yield to maturity on a financial instrument that costs you $100 and will deliver $110 out 1 year is 10%. For simple loans, these are going to be essentially the interest rate, right? It's the exact same thing, right? A simple interest rate equals the yield to maturity.